Assalamualaikum and greetings to Madam Mimi. We are from Group 8 and going to present on some application of function and differentiation in daily lives. Our members are Siti Laylatul Fazana, Wanur Arfa, Farah Ezwina, Christina Ayuni, and Akila Awatif. Now, let's look at some situation that we can apply function and differentiation in daily life. Enjoy.
Today's a good day. And look at that. That's why we are for. Let's do. Hi, baby. Oh, yes. Okay. Last week, you told us that you want to impose a tax on product A. How can we do that? First, we need to find the new equilibrium price and quantity without tax, and then with tax of 4 ringgit. And lastly, make and analyze the impact of the tax on consumers and procedures. Alright, take notes, people. Thank you, YB. See you again. Bye-bye. Bye-bye. Let's go. Okay.
Based on situation 1, we know that the government imposes a tax on product A, affecting both the supply and demand. The equilibrium price and quantity can be modeled using composite functions that incorporate the tax effect. Given that the demand function dP equals to 100 minus 2p, where P is the price, while the supply function is Sp equals to 20 plus 3p, and the tax function Tp equals to P plus T, where T is the tax per unit. So based on situation 1, we need to find the new equilibrium price as well as the quantity without tax first. So we need to, as a solution, we need to demand function equals to supply function. So 100 minus 2p equals to 20 plus 3p. So we bring the p to the left side and the numbers to the right side. We get 3p plus 2p equals to 100 minus 20. 3 plus 2 equals to 5p. 100 minus 20 equals to 80. To obtain p, we must divide 80 divided by 5, which will get 16. Therefore, 16 is the new equilibrium price without tax. To obtain the quantity without tax, we will need to substitute the value of p in either of the functions. So when p is 16, equals to 100 minus 2 times 16, which we will obtain 68. Hence, the quantity without tax is 68.
In this slide, I will discussing how to determine the equilibrium price and quantity after imposing a tax of 4 ringgits. We are given a tax t equal 4, which means that the price customer pay includes this tax. The demand function provided is d of p equal to 100 minus 2 in bracket p plus 4. The supply function is set up based on the tax. First step, we have to find the equilibrium price. To find the equilibrium price, which is the price where the quantity demands equals to the quantity supply, we start by substitute the tax into the demand functions. Since customers are paying an additional 4 ringgits, the price to them is p plus 4. We set up the equation 100 minus 2 in bracket p plus 4 equal to 20 plus 3p. By expanding and solving this, we get 92 minus 2p equals to 20 plus 3p. By isolating p, we find that p equal to 14.4. Second step is determining consumer price. Since the supplier price is p equal to p 14.4, the price consumer actually pay with the tax included becomes p plus 4, which is 14.4 plus 4 equal to 18.4. The last step is calculating the equilibrium quantity. To find the equilibrium quantity, we substitute the consumer price of p equal to 18.4 into the demand function. D of 18.4 equal to 100 minus 2 in bracket 18.4. The answer will be 63.2. Therefore, the equilibrium quantity is 63.2 units.
Next, in this slide, we will analyze the effect of a tax imposed on a product, specifically focusing on how it impacts both consumers and producers. When the tax is introduced, consumers experience an increase in the price of the product from Rm 16 ringgit to Rm 18.14 cents. This is a noticeable increase of Rm 2.14 cents, making the product more expensive for buyers. Additionally, this price hike leads to a decrease in the quantity demanded, which drops from 68 units to 63.2 units. For producers, the price they receive for each unit falls due to the tax. Initially, they receive Rm 60 ringgit per unit, but now this dropped to Rm 14 ringgit 0.14 cent, a decrease from Rm 1 ringgit 60 per unit. Consequently, the quantity sold also decreased from 68 units to 63.2 units, similar to the reduction in consumer demand. For the tax burden, the total tax revenue generated from this tax can be calculated since the tax per unit is Rm 4 ringgit and the quantity traded is now 63.2 units. The total tax revenue amount for this is 4 times 63.2 equals to Rm 252 ringgit 0.18 cent. For the deadweight loss, the tax result in a deadweight loss, which is the economic loss due to a decrease in the traded quantity. This deadweight loss represents the lost mutual benefits that could have been shared between consumers and producers had the tax not been imposed. In summary, the tax increased the price for consumers, reduced the amount received by producers, and decreased the traded quantity. While the tax generates revenue, it also creates an economic efficiency through deadweight loss.
Look what I bought. Differentiate? Yes. Wow. Have you ever thought how many companies will think to sell to maximize their profit? I thought one sales always create more profit, but now I'm not sure.
Sometimes there's a sweet spot. The perfect number of cups that let you make the most profit without overlooking costs. Imagine there's a target number of cups to take that you the customers between income and expenses. The number will be like sweet spot for your profit.
After applying the calculation to real profit, smart to move on. That's right. In fact, we are looking for the best kind of make their profit up there here. I see.
Here's a step-by-step explanation of the calculation. First, we need to define given function. Revenue function Rs equals to 200x minus 2x squared. Cost function Cs equals to 50x plus 20. Profit margin function Ps equals to Rs over Cs, which is U over V. Secondly, we need to differentiate using the quotient rule. Since Ps equals to U over V, we use the quotient rule for differentiation. Here, U equals to Rs equals to 200x minus 2x squared. V equals to Cs equals to 50x plus 20. Find dUdx and dVdx. Differentiate Rs with respect to x, which we will get 200 minus 4x. And then differentiate Cs with respect to x, and we will get 50. Next, we will apply the quotient rule. Substitute U, V, du, ds, and du and dvds into the quotient rule. And then expand and simplify the numerator. Expand the term in the numerator. We will get negative 100x squared minus 80x plus 4000. So, we set the derivative equal to 0. Negative 100x squared minus 80x plus 400 equals to 0. This is a quadratic equation which we can solve using the quadratic formula. And then we solve for x. Taking the positive solution, we get x equals to 5.93. So, the conclusion, to maximize the profit margin, the coffee shops should sell approximately 6 cups.
Alpha, did you try your box here?
No, I don't think so. Wait.
Well, I can just find out using differentiation. Hello, my name is Maino Arfa binti Wanyahya. My matrix number is A4901. Today, I will talk about differentiation and its application on an open box. The diagram below shows an open box with a square base of side x centimeter and a height of h centimeter. The box is made from a piece of cardboard with an area of 75 centimeter square. For question A, they want us to show that the volume of the box v centimeter cube is given by v equal 1 over 4 times 75x minus x cube. For this, we will need to find the h using the area equals 75. Which then we will get h equals 75 minus x squared over 4x. And we will take this value of h and replace into the equation v equal x squared times h, which then we will get the answer same as the given one. And for question B, we will need to find the value of x such that the volume v is maximum and also the maximum volume of the box. For this, we will need to find the v maximum using the dv over dx equals 0 to find the x value. And when we got the x value, which is 5, we will replace it into the v equal 1 over 4 times 75x minus x cubed, which we will get v equals 62.5 centimeter cube. And then we will use the second derivative formula, d square v over dx square, when x is 5, to find whether v is maximum or not. Which then we will get the d square v over dx square is negative 7.5, which is below 0. So the volume of the box is maximum. Hence, x equals 5 when v has a maximum value, and the maximum value of v is 62.5 centimeter cube. That's all from me. Thank you.